All right, hey again, Honors Chemistry. So this is part 2 of the video notes. So we're going to talk about how we could measure pressure, and then talk about recording measurements with pressure. So one big way that scientists discovered pressure was through this barometer business. First, it was with a water barometer, but then we mostly used mercury. So a barometer was developed and used to measure pressure. And the way it worked is atmospheric pressure pushed down on the mercury, and the mercury also pushed down, and it left an empty space or a vacuum. A vacuum is a space that has no particles, so there are no particles of matter in here, in a vacuum. So there are no particles of matter in a vacuum. And people think a vacuum is suction, but a vacuum is not suction. I spelled that wrong. Vacuum is not equal to suction. The only reason why you have suction in a vacuum is because of a change in pressure. So a side note, and we did this in class, if I have a straw and there's particles of liquid moving in here, also in the straw are particles of air that's moving down, okay? Now, the only reason why you're able to get particles of liquid into the straw is you remove particles through sucking, right? You suck with your with drinking with your lips in your mouth, and so the particles leave, and what you create is a momentary vacuum with the straw. This is kind of like this is not good drawing, but this is a before and after. And so now there's no air particles in here, and because of that, these liquid particles are able to push up now. So when you're drinking through a straw, you create a vacuum. And because of that, particles move from high pressure to low pressure, or pressure to zero pressure. So that's why particles move up the straw. It's not because of suction, it's because you're creating a vacuum. You're removing particles from the straw, and then the liquid particles are able to go up there. All right. Similarly, with a barometer, what they did was they filled a tube with mercury or water all the way to the top, and then they put it upside down and opened it. And then the height level that the mercury or the water went to is equal to the pressure. So the height was equal to the pressure in a barometer. And that's because this was pushing down, and so was the mercury. And when the mercury was pushing down, it was also pushing down at the same force that the air was pushing down. So this height is when the pushing of mercury was equal to the pushing of the air. Push of mercury was equal to the push of air. That's where this height came from. Now we aren't going to be talking about taking measurements in a barometer, but that's how a barometer worked. When they first used barometers, they used a water barometer, and it's not even shown into scale here, but it had a height of 10.3 meters. And as you could see, the height of a mercury barometer is a lot smaller. It's actually 0.76 meters. And the reason why the mercury drops lower, mercury is lower, and here are its densities between water and mercury. Mercury is lower because it is more dense. That means more particles take up less space. And as you've always said this with things that are more dense, they are more compact. So we're able to use a mercury barometer, and it's a lot smaller. And we prefer mercury over any substance because its height in a barometer is the shortest. And this is an answer to a question on worksheet number 2. Right? So I can't use normally on a regular day rationally a 10.3 meter barometer. That's like about 35 feet tall. Right? That's really tall. That's somebody who's 6 foot tall 5 or 6 times. Right? So that's 5 times 5 to 6 times somebody who's 6 feet tall. Right? So imagine somebody who's 6 feet tall 5 or 6 times up. That is irrational for me to use. But this very small barometer is like less than a meter. This is less than a meter, which is less than 3 feet tall. Okay, so it's more useful to use a mercury barometer than it is to use a water barometer. And again, this whole barometer is air pushes down, and so does the mercury. And when it stops moving, that height is the pressure. It's because the pushing is equal. Now, another type of pushing we could talk about and use are manometers. Okay, so there are 3 different types of manometers, and a manometer is a U-shaped instrument. It's just a barometer that's kind of like bent. There are gases in a tube, and it's pushing the mercury. This is mercury. Hg is mercury, by the way. Okay, and so the gas pushes, and so it's open to the air. It's open to the air. And you can read up here, like, specifically what a manometer is. But basically, air pushes down, and so does the gas. Now, there's going to be different heights. There's 2 heights. And you're always going to be looking at this height difference. Okay? And now, the air pressure is either going to be known as, like, the pressure of the room. So, atmospheric pressure. It's usually going to be said as, like, P of the room. Or the barometric pressure. That's what it's going to say in a problem, or if you see that in the future. The pressure of the room is the atmospheric pressure or the barometric pressure, and that's P atmosphere. So that pushes down, and the gas in these tubes also push, and it moves this mercury, and it's going to move it in 3 different ways. Now, if there is no change in height, if there is 0 height difference, meaning the height of the mercury on the left side and the height of the mercury on the right side is the same, that means the pressure of the gas is equal to the pressure of the atmosphere, right? And I like to say HD is 0. HD is what I call height difference, okay? Now, when it looks like the open side is higher, that means my pressure of my gas is pushing harder. So my pressure of my gas is pushing harder than my air, and because of that, the pressure of my gas is going to be greater than the pressure of my atmosphere. And so what do? To figure out the pressure of the gas, I add the height difference. P of Hg is going to be equal to the height difference, Hd. Right? I'm calling HD height difference. You add the height difference to the atmospheric pressure, and that's going to be equal to the pressure of the gas. And then finally, the last one is if it looks like the open end side is pushed down more, and it looks like it's actually pushing against my gas, this is because my atmospheric pressure, if it's lower on the open side, that means air is pushing harder. And because of that, the pressure of the gas is going to be less than the atmosphere. So what I'm going to do with this height difference, again, height difference is the difference between the left and right side heights, and we'll see an example. I'm actually, and since the pressure of the gas is going to be lower because air is pushing harder, it's going to be lower than air pressure. So what I do with that height difference is I subtract it. Okay, and so now let's do a couple of examples where I use these 3 things, because that might not make sense until you actually see it. So here's example 3. Okay, and this is for the rest of the unit notes. So the pressure of the room, or the atmospheric pressure, or the pressure of air, is going to be equal to 755 millimeters of mercury. And so here's gas particles, and here's a height 1 and a height 2. Right? I have the height on the left side is 102, and the height on the right side is 190. It says, what is the height difference of the mercury in the manometer? So height difference, HD, is going to be 190 millimeters of mercury minus 102 millimeters of mercury. If I do this math correctly, I get 88 millimeters of mercury. For organization purposes, I would say the first thing you do is get this height difference, and a positive height difference, doesn't matter, right? And then you're going to figure out whether or not I'm going to add it, subtract it, or do nothing with this height difference, okay? So now we have to look at this and say, which has a greater pressure, the air or the gas? Well, it looks like it's higher on the open end. And as mentioned up here, if it's higher on the open end, it means the pressure of my gas is pushing harder. That means it's pushing down more. It's pushing more against the air. And because of that, my pressure of my gas is greater than the pressure of my air, which means I add the height difference. And so now what I do is I use this equation. P of gas is equal to P atmosphere plus PHG, or P of the height difference. P of the gas is equal to P of atmosphere plus the height difference. So atmosphere was 755 millimeters of mercury plus 88 millimeters of mercury. And if I do this math correctly on a calculator, 755 plus 88, I get 843 millimeters of mercury. Okay, let's do another example. Same idea, right? The first thing you should do, doesn't even matter what the problem is. If you get a manometer, which is this U-shaped thing, I would get the height difference. And that's the first thing. It says, what's the height difference? So height difference is going to be equal to 120 millimeters of mercury minus 50 millimeters of mercury. And that's equal to 70 millimeters of mercury. And so now what you got to do is, am I going to be adding or subtracting this height difference? So I look here, it looks like it's lower on the open end. This means that my P of air is pushing down more. P of air is pushing harder than the gas. It's shorter on that side. It's pushing up against it. So that means my P of my air is greater than the P of the gas, right? Or we say P of the atmosphere. And so now if I want to get the pressure of the gas, if I look on the previous page, if it's lower on the open end, I'm going to subtract the height difference. So I'm going to do P of the gas is equal to P of atmosphere minus the height difference. So atmosphere is 763 millimeters of mercury, subtracted by the height difference, which is 70 millimeters of mercury. And if I do this on the calculator, 763 minus 70, I get the answer of 693 millimeters of mercury. Okay. I'm going to end this video with you trying to do example number 5, which is also in worksheet number 3. If you want to check your answer, on this process, you should get 773 as the answer. So make sure you know how to do this and see if you get the answer of 773. Alrighty, that ends the video notes for Unit 2 important information on gases and pressure. Use this to help you with dimensional analysis of converting between units and reading manometers and barometers with gases.